Okay, second assessment over inequalities is for some people it didn't go really well the first time. When you solve a greater than or less than for a variable, there's an infinite number of answers, so we make a number line to represent our answers, show our set of answers. So first thing I need to pay attention to is the x variable. Is it being it's not even being multiplied or divided, so the sign's going to stay the same. It's a positive x. The x is positive. So we undo the plus 6 by minusing 6. That's the only operation I have. So x is over here. That's good. And I take negative 9, subtract 6. I get negative 15. Okay, so negative 15 is a critical number. We fill in the circle because it can be equal, and then anything less than negative 15. Okay, the next one, negative 2x. That means negative 2 times x is greater than negative 16. Okay, so x here is being multiplied. And the x term, the x, we have a negative with it. Okay, so it's being multiplied by a negative number. So that sign turns around. Okay, and also let me explain how this works again. Let's say I have picked two random numbers, 10 and 20. Well, 20 is bigger, but you see if you divide it by just 2, then you end up, if you divide that by 2 and that by 2, you have 10 and 5. 10's bigger. The sign didn't switch. Now, if I were to divide that by negative 2 and that by negative 2, then it would be negative 10 and negative 5. Well, now negative 5 is bigger, so it changes. Okay? So, if we have to divide by a negative, then the sign flips. So I'm going to divide by negative 2, divide by negative 2. We have x where on the side we want it, and then that gives me positive 8. So x is less than 8. Okay, now 8 isn't actually part of the solution set, so I don't fill it in. It just goes left. Anything that way. Okay, the next problem. Is x being multiplied or divided by a negative number? Yeah, it is being multiplied by a negative number, so that sign has got to flip. So plus 2, plus 2. Now, I'm not ready to fill out my answer because I still have the multiplication by negative 3 I need to undo. Okay, so I have negative 3x, and that's 9. Now, I undo the multiplication through division, and I have x, and then 9 divided by negative 3 is negative 3. So that's my solution set. So negative 3 is my number, fill it in, and you can go anything greater than. Again, you have to pay attention if x is being multiplied by a negative number. It's not here, it is here, so the sign switches, and it is here, so the sign switches. Okay, 3x plus 8 minus 8x is greater than 13. So, I actually have x appearing twice in this inequality. Well, I need to make it appear only once. So I take the x terms. Now, they're on the same side here. So if they're on the same side of the inequality, we connect it through addition. Okay, and remember that 8's negative now. So 3 plus negative 8 is negative 5x, and then we've got to remember to add the 3, greater than 13. Okay, now that x appears once, I can see that it's being multiplied by a negative number. So the sign will flip, and we'll be going that way with it. So I undo the addition of 3. That's 10, so we have negative 5x, and then 10. Then I undo the multiplication of negative 5. So I have x, and the sign has been flipped, and then that gives me negative 2. Okay, so negative 2 is our critical number, but negative 2 does not get shaded in, and it goes that way. Okay, and then the next page we got more inequalities to solve. Okay, x again appears twice in the entire inequality. So now they're on opposite sides. So now that 4 is a positive, so I do the subtraction property of equality. I can't just add the terms together. Then I'd subtract that from 3x. So that gives me negative 1x minus 4 greater than or equal to 6. Now here's x. It's being multiplied by a negative, okay? So that sign goes the other direction. So then I undo the minus 4 by adding 4, and that's 10. So negative 1x is greater than or equal to 10. But then I divide by a negative on both sides. So x is now less than or equal to negative 10. Okay, so negative 10 is my critical value. Fill it in, and then we go this way with it. Okay, now the next one, we have 2 times 1x plus negative 8. You distribute the 2. You don't want the parentheses there. 2x plus negative 16 is less than 16 plus 2x. Okay, again, x appears twice in the inequality. They're on opposite sides, but they're the same exact term, 2x, 2x. So they cancel right here. So I won't be needing this number line. It's either all solutions or no solution. Now I have a negative 16, a positive 16. So here's my larger value, and the sign opens up towards 16 as it should, so that makes this all solutions. That means x can be any number, and then this side is less than this side. Any number you put in for x will make this side less than this side. Okay, now some people blacked out on this problem here where there's 2 signs. So let's go find our x. It only appears once. It is being multiplied, and it's being multiplied by negatives. So these signs, both of them, need to switch. And we want x in the middle by itself. Okay, so I got to find the 2 numbers that x is between. So look in the middle. We have a plus 6 we have to undo before we divide by negative 3. So I'm minus 6, and then I subtract 6 from negative 15 and 24. So that gives me negative 21. My inequality, negative 3x, less than or equal to 18. Then we undo the multiplication of negative 3 by dividing by negative 3. And then I essentially have my solutions. I have positive 7 and negative 6. Now we can't stress ourselves out about which way the arrows go, because we know they're going to run into, they're just going to collide towards each other. Okay? Because this, writing a compound inequality like this means x can be between, the solution says anything between these two, including these 2 numbers, because it's equal. Okay, so just remember, the key is once you get x to appear once, you pay attention if it's being multiplied or divided by a negative number. If it is, the sign's going to switch. I guarantee it. If it's not being multiplied by negative, the sign's not going to switch. You don't have to write this down, just watch it. So if I had to solve that, x is being multiplied, but it's not being multiplied by negative, so the sign stays the same. And then we minus 8, that's 8, then divide by 4, and that's 2. So I'm not flipping the sign because x is not being multiplied by negative, it's being multiplied by positive 4. All right, now graphing. What you're doing is finding combination coordinate points, xy coordinates that make y greater than or equal to negative 1/3 times the x plus 7. Okay, so y and x are here. They're on opposite sides, so that's in slope-intercept form. So remember, slope and y-intercept. Slope is m, which is in front of x, plus, and then the y-intercept's b. That's why it's called y equals mx plus b. So slope's negative 1/3, and then 7's my y-intercept. So 0, 7, 1, 2, 3, 4, 5, 6, 7. Then from there we go rise of negative 1, so that's down and to the right. Rise over run. 1, 1, 2, 3, 1, 1, 2, 3. Now we do have the equals, so that, oops, I'll get a ruler. I don't have a ruler. Okay. It's not like it has to be perfect anyway. I don't need the lines to cross. Okay, so anywhere on this line is y greater than or equal to negative 1/3 x plus 7. Now I have the equals. That's the full line. Okay, those are all the points that make this side equal to this side for y and x. Now to find the greater than side, we do a test. Okay, a true-false test. 0, 0. And I replace my y and x with zeros. Okay, so parentheses is greater than or equal to negative 1/3 parentheses plus 7. And we're just going to fill the at y and the x with this coordinate, 0, 0. So I don't have any operations over here, that's 0. Over here I do. I have to take 1/3, negative 1/3 times 0, well, duh, that's 0, plus 7, 7. Okay, here's my larger value. The sign is not opening up towards 7, so that makes that a false. So at this point, when I replaced x and y with those, I got false. It means this whole side's false. The other side of the line is my true. All the little points up here. Okay, don't actually do this. I'm just making a point here. This next thing. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So let's say 6, 6. Don't do this, okay? I'm just proving a point. So if I replace these with 6 and 6, I have 6 over here. Now on the other side, I take negative 1/3 multiplied by 6 plus 7, and I get 5. Well, 6 is bigger than 5, and the sign opens up towards that, so that's true. So any point here is true. Any point you do over here is false. Okay, the next one, the y and the x are on the same side, so that makes this in standard form. Okay, so standard form. So 0, 0. So I write that out twice with an equals sign, just a regular equals. Because I'm just finding the line's all about equals. So x is 0. Then we divide by 6. So negative 18 divided by 6 is negative 3. And here the y is 0. So I divide both sides of the equation by negative 3. And that takes me to 6. Okay, so 0, negative 3 down 1, 2, 3. And then 6, 0. 1, 2, 3, 4, 5, 6. Okay, we don't have the equals to, so that's just going to be a dash line through here. So we have negative 3x plus 6y greater than negative 18. Now, it doesn't say equals, and that's why the line has been cut or dashed. Now we find what side's greater than. So let's 0 and 0. And we replace x and y. So I've got negative 3 parentheses plus 6 parentheses greater than negative 18. Just empty those. 0. Okay, now I know there's a lot of operations over here, but when you're multiplying, you have two multiplications of 0. I'm pretty sure that whole side's 0, greater than negative 18. Now 0 is larger than any negative, so it opens up to the larger value. That's a true. So that's true on that side. This side's false. The next page you can't see, so we're not doing it. Okay, a concession stand must spend $200 on supplies to make glaze. Oh, here's what I'm going to change this. Okay, I'm going to cross out the 200. I'm going to put $2 per donut. Okay. So a concession stand must spend $2 per donut on supplies to make glazed donuts. They're going to be selling the donuts for $2.50 each. How many donuts do they need to sell to make a $200 profit? So profit's key. So I want to make my chart where I put sell and spent. Okay. Then, okay, so what am I selling the donuts for? When I sell the donuts, what are they going to be sold for? we're going to sell them for $2.50 each. Now it's each, so it'd be $2.50x because I don't know how many of them there are. Now spent. What are you spending to make the donut? Okay. Oh yeah, by the way, profit, you want to put greater than or equal because you can go over your profit and it'd be 200. Okay. So I have 200 and I put 250. So the spent, there's only going to be one amount for sold. You're selling them for, you're only selling donuts. You're going to sell them for the same amount. Now spent, we have $2. We're spending $2 per donut. So 2x, and that's a negative. Okay. So when I sell it, I make positive. When I spend it, I make negative. Okay, now these are both x's, so we want to add the x's together. 2.50 plus negative 2, so it's going to be 0.50x. Then I divide both sides by 50 cents. Okay, 200 divided by 0.50, I got 400. So x greater than or equal to 400. Again, I'll repeat that again. Whenever you're doing a profit, sell, spent. Or you can put money made and money spent. Okay, I don't really care. But when you're selling the donuts, you're selling them for $2.50 each. Okay, that's the only thing you have to worry about. Then your profit you want, that's going to be $200. And then you got to put how much you're spending on each donut. $2 per donut. Make that negative. And then these are both x's, so they get added together. Profit is what you make minus what you spent. Okay. Selling pretzels and popcorn, I want to make $300. Pretzels cost $2 each, and popcorn costs $2.50 each. Graph a representation of combinations of pretzels and popcorn I can afford to sell. So let's have X be pretzels and Y be popcorn. Okay, now, to graph this, you want to make $300. You can go over that if you're the one selling it, okay? So greater than or equal to. And then go blank X plus blank Y. Think of blanks, blank X plus blank Y. So X-axis, we have pretzels, and you can switch them around. It don't matter. So pretzels, those are $2 each. Times how many I sell. And then the popcorn's $2.50 each. Okay, I have to graph it. The X and the Y are on the same side, so that's in standard form. Okay, so 0 and 0. So I write that out twice. 2x plus 250y equals 300. 2x plus 250y equals 300. So x can go bye-bye here. Y goes bye-bye here. Divide by 250. Divide by 250. So I will take 300, divide by 250, and I get 120. Okay, and then here we'll divide by 2, and that's going to be 150. Okay, I'm going to go by 20s here. So 0, 20, 40, 60, 80, 100, 120. Okay, so I'll mark that off. 150, I'll go by 20s. 20, 40, 60, 80, 100, 120, 140, 160, so it'd be in here. Okay, you can be equal. So 2x plus 250y is greater than or equal to 300. And it's greater than, so the true is the outside of the triangle, the false is the inside. Okay, absolute value, distance from 0. That's 6 units from 0 plus, that's 4 units from 0, that's 10. Okay, you do your operation, you have -5 here, and 10 here. So -5 is 5 units from 0, 10 is 10 units from 0, so it's 15. Okay, the absolute value of 10 minus 12 is -2, or 2 is -2, and then that's -4, and then that's 2 units from 0. And we have a minus, that's 4 units from 0. That's a negative, okay? Don't put 2, okay? because your absolute values have been eliminated. Okay, then we're solving equations. Equations where with absolute value always have two answers. So inside you have x. Well, to be 5 units from 0, we could be at 5 or negative 5, either one. Okay, now inside we have 4 times x minus 2. And there's no operations outside, so I could be at 6 or negative 6. Then I add 2, that's 4x equals 8. Divide by 4, so 2 is a possible answer. Negative 6 plus 2 is negative 4. Divide by 4, I get negative 1. Okay, now here inside of our absolute value, the expression's x minus 3. But we got some operations to undo. We have a plus 4 to undo first, then a times 3 to undo. So we subtract 4. That gives me 9. 3 times the absolute value of x minus 3 equals 9. And then I divide by 3. Remember, divide by 3, don't minus 3. The opposite of times is not minus, it's to divide. So that's the absolute value of x minus 3 equals 3. So now that the operations outside are all gone, you have an absolute value that equals 3. Well, you could be at 3 or negative 3. Plus 3, I get 6. Plus 3. Negative 3 plus 3 is actually 0. Okay. So a lot of mistakes on this problem here. The absolute value of negative 2 is 2. Minus the absolute value of negative 4 is 4. Now the absolute values are gone at this point, and you just do math. 2 minus 4 is negative 2. Okay, and a lot of misses on that one. They thought it had to be a positive answer at the end. It doesn't.